Welcome to the Tech Ranch, live and local here on Super Talk 1270. The latest gadgets, online security, websites and apps, social media, and so much more. How can technology help you? Let's find out. It's time for the Tech Ranch on Super Talk 1270.
Hey, good morning. As you can tell, this is not the Guru of Geek by any means. In fact, I've been trying to figure out if there's a new name for me, and so I have been using Rockin Dave, and I guess I'm going to continue using that.
Yeah, it works.
Our friend Marlo, he's on a cruise down in the Caribbean someplace with his family. So anyway, we'll have to give him a little crap when he gets back here in a couple of weeks. Yeah. You know, you're going to have to put up with me for a couple weeks. So, hey, I'm very excited to be hosting this show again. I don't know why Marlo has all the confidence in the world with me, but maybe because he couldn't find anybody else. So, and you know, the Guru of Geek also has his side partner, the Tech Geezer. Yes, and it's always good to have him around. But, hey, this morning's kind of exciting times because I'm very happy to have in the studio with me Terry Pilling. And Terry is a professor at the University of Mary. For all of you that don't know, Mary is starting a engineering school out there. And Terry's pretty excited to launch the program, and I'm going to let Terry just give you a little snapshot of himself, and we'll talk a little bit about education in the world of technology. So, hey, Terry, great to have you on.
Hi, Dave. Rockin Dave.
Rockin Dave.
You can call me Dr. T.
Oh, right,
Doctor of rock and roll.
There
Doctor
we go. There we go.
Scary Terry.
Well, my background, the Cliff Notes version, originally from Canada.
Yeah,
And,
amen.
Sure am, eh? Mm-hmm. Hoser. I did my undergraduate degree in engineering physics at the University of Saskatchewan. And then I did a master's degree in nuclear physics at the Saskatchewan Accelerator Laboratory.
Ooh.
I did my PhD in theoretical high-energy physics and string theory at NDSU.
Whoa.
And then I did postdoctoral work at the Joint Institute of Nuclear Research in Russia.
In Russia?
In Russia.
Oh, wow.
And at the Joint Astronomy Center in Hawaii at the telescopes on top of Mauna Kea. Then I taught at NDSU for 6 years.
Your career is kind of like mine. It's almost a mirrored image. I can't believe that, Terry.
I figured that. Yeah, NDSU for 6 years, and then I came out west to serve at the as the chief operations officer for a wind power company. And then I was invited to build an engineering program at the University of Mary, and that's where I am now.
Wow, that's amazing. I mean, I didn't, I've only known Terry for a couple months maybe, and didn't realize how broad a background you had, and maybe that's another time we'll invite you back and you can talk about all those experiences you had in Hawaii and in Russia and that whole nuclear program too.
Absolutely.
It's amazing that we have a guy with his ability here in the studios, but also is committed to making a difference and getting students engaged in following a career in engineering, because it is a great time to be in the United States with all the new technologies happening. Yeah. Well, one of the things that I guess I wanted to ask you is, maybe you can give the audience just a little bit of background on what you guys are going to be doing out of the University of Mary in regards to the engineering programs. What are you going to be concentrating on? And then I want to talk maybe a little bit about, hey, if there's students out there, and probably they're not listening to this, but mom and dads are, if they want to get into engineering, how do we prepare them for that? But maybe you can give us just an overview of your engineering program at University of Mary, if you wouldn't mind, Terry.
All right.
Or Dr. T.
Dr. T. Well, at the University of Mary at the moment, we have a civil engineering, mechanical engineering, and electrical engineering program, and we also offer petroleum engineering and chemical engineering, but those have courses that you'd take online from UND while staying at the University of Mary campus. We're working on blueprints at the moment, and very shortly we'll be starting construction of our new engineering buildings, and those include laboratory facilities and concrete testing facilities and a lot of interesting things going on out there, and they should be complete by this time next year. So we'll have our full program going. We already have almost 70 students enrolled in engineering at the University.
That's great.
One thing that we're doing, I think, that's different from a lot of schools is that you may have heard, although I think this might be unknown, but engineers have a stereotype of being a little bit nerdy.
No, really?
Yeah, they do.
Oh, okay.
And having poor social skills. And so one of the things that we're adding to all of our courses at the University of Mary is presentations, public speaking, selling your ideas, things like that are part of each course so that the students will come out with these skills. And, of course, they'll still be nerdy because that's just part of being an engineer. But they'll also be able to communicate their ideas to the general public in a more effective way.
Communication skills are so important in every single job, and I think that's very noble of you to try to get those engineers kind of out of their little box and saying, hey, guess what? You guys have to be part of the community. You have to express yourselves. So, well, good ideas.
One of the things I do in my circuit analysis class this semester, for example, is, and we're trying to do this with most of our courses, is that we're combining the labs and the courses into one room. So, for example, my circuit analysis class is conducted in the electronic circuit lab. And every student brings their own Raspberry Pi computer to class with them, which is a small computer and costs about $30, but it's extremely powerful and you can do electronic simulations with it. And so when we're doing a particular problem like building an electric circuit, what we'll do is we'll first do the mathematical theory, which is normally what's done in the classroom, and then the lab would be a separate thing. But the way we do it is we'll go up and do the mathematical theory and calculate all the equations for the circuit, and then we'll pull out our Raspberry Pi computers and do a simulation of the circuit using electronic simulator called SPICE, which stands for Simulation Program with Integrated Circuit Emphasis, SPICE.
I'm not going to remember that. Okay, I'm sorry, Terry.
And then they see that the SPICE simulation gives the same answers that they got using heavy-duty mathematics. And then finally, we pull out our breadboards and our circuit elements, and we construct the circuit and take measurements with oscilloscopes and multimeters and find that we get the same answer physically with the actual circuit that both the simulation and the mathematics gave. And I think it really is a good way of teaching it.
Wow. So it's more than just theory. It's actually applications and getting them involved. And from what you've just explained, it sounds like it really gets the students more engaged into those whole application processes. So, hey, we've got Terry Pilling here with us from the University of Mary. This is Rockin Dave Blair filling in for the Guru Geek, Marlo Anderson. We're going to be talking a little bit more about how you prepare your possible students and kids out there for high school to prepare them for programs in engineering. So we'll be back here and look forward to more conversations here with Terry.
Right now, 50.
The home for ABC News at the top of the hour is Super Talk 1270.
Hey, this is Rockin Dave Blair. I think you guys have come to know me as the Guru of Not Geek, but the Guru of Geek obviously is not here, Mr. Anderson. But we've got Dr. T with us, and we got the Tech Geezer with us too, and so we're going to talk. We're going to talk a little bit more about what Terry's doing out at the University of Mary, and then we're going to talk a little bit about, hey, if you got some kids that are interested in engineering. How do you prepare them for engineering college classes? So, hey, Terry, Dr. T, I know you wanted to kind of maybe talk a little bit more about another couple programs that are happening out there at University of Marion. I just want to make one more comment. If you guys haven't been, if you've been in Bismarck and haven't been out there at University of Marion campus, man, it's just growing and expanding. It's a beautiful location, beautiful campus. So, Dr. T, take it away.
Well, one thing that we can use from outside help, some outside help with, is soon we'll have a website up, and that website is intended so that companies, industry, engineering firms can post projects that are of interest to their firm, and then our students can use those projects or select from them for their senior design course. Every engineering student has to do a senior design course in their senior year where they build and research a project of interest. And one thing we're doing slightly differently from other schools is that we would like projects to be submitted by industry for that. And then our students can work on those and hopefully come up with some interesting solutions that the industry hadn't thought of. One thing we want with our senior design projects is we encourage them to have at least one student from civil, from electrical, and from mechanical engineering on their design team, because I think, as we all know, in the real world, most engineering projects include various kinds of engineers, especially nowadays where there's computers and microcontrollers and electronics in everything. You can hardly build a bridge without computers being involved. So I think all kinds of engineers need to have a fundamental knowledge of computer science. You
know, it's so interesting. I worked for an engineering firm for about 14 years, and one of the things that I've always picked up on by working and most of the practice for this engineering company was civil engineering, but it was like, hey, you know, you can teach students something about whatever they're interested in, but you really got to listen to industry too and what they need from those students to prepare them to move into the workforce, because ultimately that's the key to.
Well, in fact, our entire curriculum is being designed by industry. For the last 2 years we've had a group of engineers from different companies all across the northern states, and we've been meeting at the Bobcat Acceleration Center once a month. And they've been going through our curriculum and adding and deleting things and making suggestions and modifications so that our curriculum is modern and it's producing exactly the kind of engineers that are needed in today's workforce.
That's perfect, man. It just lines up with is that whole connectivity between education and industry. And I really think it's awesome that you guys are going in that direction. You know, I think the next step I just really wanted to, and I wanted to get the Tech Geezer involved with this. You know, when you were going to high school, you know, were you ever looking at engineering, and what were some of your issues that you had going into that, looking at it?
Math.
That's
okay.
common.
Yeah.
I tried to count to 21 one time, and I got arrested. I have no idea what he meant by that. We're going to send him down the hall for some coffee.
Huh?
Well, you know something, things have changed a lot since you went to school and I went to school now. The geezer, you know, we just have to put up with him once in a while. But
he was there when calculus was invented.
You know, it's important to teach kids in high school and elementary school about computers, but one thing is that kids are almost born with a cell phone in their hand these days, and I bet if you talk to any of them, they know more about computers than you did at their age, and maybe more than you do now.
Right. Yeah.
And so we shouldn't overemphasize learning how to use computers. They'll get that on their own because today's society depends on it. What they don't get on their own is math.
What about that fear of math? A lot of folks have it. A lot of young people have it.
Math is like any other subject. It's extremely interesting as long as someone who's interested, genuinely interested in it, is the one showing you.
Right.
Like, so for example, you could be walking down the street and see somebody, you know, weaving a basket even, and you'd say to your friend, you know, that looks like a boring job to be doing all day.
Mm-hmm.
But if you sat down and talked to that person and they explain all the different kinds of reeds and the properties of it and the moisture and how you make these different knots and everything else, it becomes absolutely fascinating. And you might walk away saying, I wish I was a basket weaver.
If they have the passion, it will come through.
That's right.
Right.
And that's what we need is the teachers to just show how really interesting it can be. Another thing to encourage kids to go into engineering would be to emphasize more science and, like we said, math, but also at home you could have them building things and tinkering and working in the shop. You could buy a little device called an Arduino. An Arduino is a microcontroller that you can use to build robots, and online they even have tutorials on building robots.
When I was a little kid, they had a thing called the erector set. You remember that?
Yeah, I do.
Yes.
Do they still have those?
Well, they have something similar called a VEX, V-E-X.
Okay.
So if you Google VEX, you can find the today's erector set, and you can make
Beautiful.
robots with it and everything.
Wonderful.
I'm still into Legos.
Legos are great. I hope they never disappear. Those things are awesome.
I have the entire Batman collection.
It's really interesting, and Dr. T. Terry pointed out about the technology and all of these kids. My grandson, who's going to be 13 here in a couple weeks, he had issues with his phone, so he was without his phone for a week. And it was like, I said, how did you handle that? Did you go through a withdrawal? And he said, it wasn't so bad. And someone, I think every once in a while, parents take that phone away from that kid for a week.
Crazy things that have pages of paper in them. They're called books. Every once in a while, you might want to read one.
Yeah, because that's
what soundbite.
That's what we're worried about. We need to have kids get still involved with reading a book. And
another thing too is that the attention span, because I think of the phone and tweeting technology and all that and Snapchat, attention spans have grown shorter. It seems. I might be wrong, but one thing that you really need when you're going into engineering or math or a technical subject like that is you need to be able to concentrate sort of undisturbed for a long period of time, because the problems are hard. And I know, like, your math problems in high school are ones you can solve in a few minutes and then go back to your video game. But when you get to college, these problems take hours to solve even one problem. And so you have to have that kind of an undivided attention to do it. And,
it's interesting bringing up my grandson again. I said, so can you have a phone in your classroom? And he said, yeah, but the only thing we can do is listen to music. So you have headphones.
Oh, really?
And, so he's in 7th grade, and I'm going, wow. In today's society, especially looking at it back when I worked at this engineering firm, I've seen a lot of the engineers, they got headsets on, and I don't know if they're listening to something or if they're really dealing in what they need to, but it seems like they're trying to isolate maybe what's going around them and concentrating on what they're doing. So things have changed so much since I went to school. And the tech geezer, I mean, he didn't even have books to write on. I know that. I mean, it was stone tablets, I believe, right?
Yeah. Well, something about the human brain, I believe anyway, is that if you force yourself to concentrate on something for the first 10 minutes, but basically it's hard to do, but you want to do something else, but you force yourself to do what you think is boring for 10 minutes, and pretty soon your brain gets captivated by it, and then an hour will go by, and next time you look at your clock, an hour has gone by, and you wonder what happened to it. Yeah. And that's the kind of mental state you want to get yourself into, especially writing computer code.
You had mentioned something really interesting when we talked last week about another concept you have, rather than just a 50-minute class, is extending that, because you do 50 minutes and then you have to then allow them to kind of digest that, but then they come back and now they have to kind of like, where did I pick off? It's like reading a book and then you leave it alone for a week and then you're going, okay, I got to try to remember.
What was I thinking?
Yeah,
before?
Exactly.
Well, that's right. We have classes that are up to 2.5 or 3 hours long. And how they work, we're just starting it this semester, but it's the class and the lab combined. So it's not somebody droning on at the front of the class for 3 hours.
Right.
Everyone would be asleep. Instead, we divided up. There's a lot of hands-on stuff right in the classroom, as well as that theory, so that I think in fact, at the end of the class, it's hard to kick the students out of there. They're still working on their stuff when I'm saying, hey, you guys, the time's up. Let's get moving now. I got other things I got to do now.
Yeah, but that's pretty exciting to see them just really engaged and going, you know, this is so boring, Dr. T. I want to go, I want to leave, but they're sticking around. So that has a lot to do with obviously you, but also what you're trying to teach them. So we're going to be back here with Dr. T here momentarily. We're going to be talking about nanotechnology, touch maybe a little bit about 3D printing. So God bless you guys, and we'll be back here in a few minutes with Dr. T.
Right now, 50.
The Red River Farm Network. Ag News is here on Super Talk 1270.
Hey, we're back. And as you might have figured, this is not the Guru of Geek. He's tanning himself, and I don't know.
Tanning his hide.
Yeah, tanning his hide. Yeah. So, Rockin Dave, Dave here with you, along with Dr. T, Terry Pilling from the University of Marion. You know, I thought we would talk a little bit about some of the new technologies, and they're not really new, but they've just kept continuing to expand and grow. And I think one of the really cool ones is the nano side of things and what's happening there. The nanotechnology. Yeah. And hey, there's probably a lot of people that don't really understand nanotechnology. So, hey, can you give us just a quick version of that, and then how you see that's applying to? Okay. Yeah, that would be great.
Nano stands for nanometer, which is a billionth of a meter. And I guess to get a handle on what that means, it's a 100,000th of the width of a human hair. Ooh. So you could line up 100,000 of them to make the width of a human hair. So that's about the scale of things. It's between micro scale and atomic scale, a little bit bigger than atoms. An atom is about 1/10 of a nanometer.
We're talking tiny, 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 tiny.
Well, the nucleus of an atom is 10 to the minus 15 meters, which is actually smaller than an atom, as an atom is smaller than a human hair. So it's another that much again to get to the nucleus.
Did you understand that, Mr. Geezer, Tech Geezer? I know he's shaking his head. He has no clue.
Well, maybe we should talk about what we can use it for.
Yeah, actually, let's do that. Let's talk about that.
Here's something that your listeners might find interesting. If they happen to have their phone handy or something, they could Google a boy and his atom. If you Google a boy and his atom, you'll see there's a video. You can see it on YouTube even. And it's a video that was made by IBM, and it's basically a film made out of atoms. They have this scanning tunneling electron microscope, and they have this magnetic probe that they can use to move atoms around on a silicon plate. And they made a movie out of atoms, so I think your listeners will find it interesting. One thing that they'll end up using for that in the future, is to reduce the size needed to store things on a computer. And also, hopefully, the size needed to make a computer. The CPU could be made smaller if we could figure out one of the problems. Maybe I'll talk about that problem later.
Okay.
But firstly, with memory, you might, I don't know, some of your more nerdy listeners might know of something called Moore's Law. Moore's Law is a sort of back-of-the-envelope law that was invented back in the 50s or 60s, by a guy named Moore, who said that every 18 months, it was 1965, every 18 months, the number of transistors in a computer doubles, which means the computer, if we want them to stay the same size as they are now or make them smaller, you have to reduce the size you need of the chip to put the transistors on.
Wow.
Well, nanotechnology may allow us to do this.
Right.
So right now, actually, if you want me to continue talking about the applications, or
I think what's interesting is that one of the things that we talked about on the break was how these applications work, and especially in regards to civil engineering and all the infrastructure that is going to be happening here and what kind of impact that could have on our society in the future. Maybe you can just comment a little bit about that, Harry.
Well, once you get this size of machines, you could do. Actually, there's a lecture from 1959 by Nobel Prize-winning physicist Richard Feynman that you might be able to find. It's entitled "There's Plenty of Room at the Bottom," and what he's talking about is that at the nano scale, there's vast amounts of room to put things and still have a very small device. And so, one of the things we can build with them is sensors, and we could construct sensor nets. So civil engineers, you mentioned, we could have sensor nets mixed right in with the concrete when you're pouring foundations or when you're pouring, interstate highways, things like that, in asphalt, in bridges, in buildings, in cars. You'd have all these sensors right in with the material that the machine's constructed out of. And then those sensors would monitor things like vibrations and temperature, cracking, shifting, moisture, all of these different parameters, and you can tell right away if there's going to be a fault in that material. And maybe our days of collapsing bridges and cracked highways will be over. Maybe we can get down I-94 here through Bismarck without having to wait an hour in traffic, right?
Wow. I'm always amazed that, even on the construction side of things and the new types of products that are coming out with for concrete and asphalt. I actually was involved with a company that had fibers that they would put in the concrete and that could replace rebar.
Yeah.
And but the technology that you're talking about with sensors and everything like that, it's here and we're trying to prepare ourselves for that as well.
There's a type of nano wire that's invented made out of carbon microtubules. If you Googled that, you'd find out about them, but they're 100 times stronger than steel. So like you were saying with these fibers, if you made them out of carbon microtubules, you might be able to get a very strong material.
Well, at some time, we're going to be coming back because we're working on something really exciting with the Guru of Geek. It's called the Wi-Fi Highway, and how that could tie in and using Highway 83 as our testing corridor. And Dr. T's been involved, Terry's been involved with some of those discussions. But the nano side of things is just so complex. I can't even comprehend that. That's because I got a real nano brain too. But
we can fix that.
We can fix that. I don't know about that.
In the biological field, you can make little nano robots that you can inject into patients, and those robots will seek out viruses and destroy them, and also cancer cells. And perhaps in the future, the cure to cancer will be an injection of nano robots.
Wow. How about, can we expand my brain capacity a little bit too, because even all of us, we don't, what do we use, 10% of our brain?
I don't know.
Something like
I've heard that, but I'm not sure.
I don't know. Mine is, I'm trying to use all of it, but I'm not getting very far. But the nano world is just such an exciting new thing about different types of new products that are out there as well.
It's not actually even in the future. We're already using it all over the place. For example, sunscreen that you buy at the local pharmacy or whatever has nanoparticles in it of zinc oxide and titanium oxide. I don't know if you remember sunscreen like Marlo's sunscreen probably doesn't have this, but it used to be cream colored or white colored when you put it on your skin, and now it's not. But it's the same thing. It's just that now we're using nanoparticles in there, and now that makes it clear instead of white.
Yeah. I hope Marlo's using some sunscreen out there, because he's going to come back burnt and he'll be complaining about it anyway. But, as we continue to talk just a little bit about nanotechnology, the other thing that you talked about was on the side of medicine and where that's going, and that's so amazing, talking about these little nanoparticles that you can inject into your system.
Well, there's already over 13,000 patents at the patent office dealing with nanotechnology, so you can see that there's just this huge increase in applications that are happening as we speak.
Yeah. Is that something you are going to be teaching out there at the University of Mary, or is that like a graduate course, or how?
Yeah, I think so. We're not teaching it directly as a part of our undergraduate curriculum, but students having gotten a University of Mary engineering degree will easily be able to find out on their own how that works, or work for a company and learn very quickly how it works.
Well, and again, that's part of what we're looking at in the future is, how can North Dakota play an important role in some of that, and the whole nanotechnology and creating a society here that really deals with nanotechnology, nanoparticles, and that kind of stuff. So I think, hey, you can be anywhere, and why not do it? Why not do it here in North Dakota or in Bismarck, Mandan, right?
Well, we may end up having research programs starting out at the University of Mary dealing with nanotechnology. So we may, in fact, be teaching our students that, but not as part of the curriculum, but part of a research project.
Wow. Well, next week I'm going to be talking about energy technology, and there again, it's really interesting what's happening out there in that whole nano world. I'm sure the energy field, petroleum, even the Lignite Energy Council, I know, has talked about some of that new stuff that's happening there in their world. So, yeah, it's exciting times, and trying to keep up on it. Thank God for Google, huh? We can just Google it, and then we can ask those questions.
Do you know where the term nanotechnology came from, Rockin Dave?
I sure don't.
Can
you're going to tell me what year?
Yeah.
I would say 1956.
Well, actually, 1986.
Oh, okay. Well, it was
a guy named
years
Eric
off. 30
Drexler.
years off. Okay.
Eric Drexler wrote a book called Engines of Creation, and in his book, he introduced the term nanotechnology, and that's where it took off from.
Wow, that's it's just so fun to hang around people that have a lot more knowledge than me, and Terry's been putting up with me now for a month or two, and it's been fun. And the world is moving so fast, and sometimes we do have to slow down though too, and just kind of saying, okay, let's figure out where we're at. And even like on our phone, that is really a computer, and how much more that's going to be able to do in the future.
Virtual reality, things like that.
Yeah, exactly. So hey, we're with Dr. T here. We're going to come back here on our last segment. We're going to be talking about writing code, and that one will blow you away as well. And so, hey, stay tuned. Really appreciate Rockin Dave Blair and Dr. T. Talking to you soon.
Right now, 59.
Here's Sean Hannity, weekday afternoons on Super Talk 1270.
Rockin Dave Blair back here with you, and it's been fun this morning, and we're gonna finish strong here with Dr. T. Terry Pilling from University of Mary, and we got a challenge out there for some of you listeners. And Terry, we're talking a little bit about the nanotechnology, and so Terry, let's throw that challenge out at them, okay?
Over the break, we were talking about what things are unknown and need to be known before we can proceed with nanotechnology, and one of them is we don't know how to make transistors out of atoms, nanotransistors. So maybe there's scientists all over the world working on it, so maybe all we need is some new ideas to come in from the outside. I don't know. If you're interested in looking at the current research in nanotechnology, you just have to go to www.archive.org, and archive is spelled ARXIV.org, and do a search. There's a search bar there on nanotechnology, and you'll see thousands of papers. This is where all the scientists publish their papers, freely available online. And so go there and you can see all the latest stuff, not only in nanotechnology, but every field.
Wow. Well, there's a challenge out there for you listeners. Hey, we're gonna change direction here a little bit, and we're gonna talk a little bit about writing code, and it's been interesting as I've talked to a lot of people out there with that are developing new companies, and a lot of them is these new apps that are out there, and writing code seems to be a challenge. In fact, a lot of what I've learned is coming out of, why is it coming out of India or Mexico or other places? And why are they so much more ahead of us in writing code, and how can we pull that back into doing more of that here in the States?
Well, every field uses computers and computer coding, not just computer science. In fact, it used to be the realm of computer science and physics, and now it's engineering all across the board in engineering as well as other fields. As far as coding, all of our students use computer code in basically all their classes. They start out with using Python, a computer language called Python, and then they just move on and learn BASIC, Fortran, Pascal, C, C++, Java, HTML, LaTeX, Bash. I mean, the list goes on. They learn multiple different programming languages until the point, really, where someone can introduce a new programming language to them, and they'll just simply ask the guy, okay, how do you do for loops in that language? How do you do while loops? How do you do this and how do you do that? And they'll just be able to sit down and write code in it without having to go through all of the learning curve.
So are you teaching how to write code out there?
In all of our classes.
Okay.
We are. For example, well, you know how computers work, of course, since you guys are the tech geeks. The computer understands zeros and ones, which is basically voltage levels, 0 voltage and then a higher voltage level. And that's how you code information into a computer, with just zeros and ones. Unfortunately, humans don't think in zeros and ones, although some, I think, can. Mostly we need to translate the zeros and ones into human talk, or in fact, vice versa. We need to write a computer programming language where we can speak in people talk, and it gets translated into zeros and ones and then fed into the computer. And so that's what a computer programming language is. It just translates between us and the zeros and ones. And so what students do is they spend a lot of time writing computer code, not only to simulate electric circuits like I talked about earlier, but also to make web pages and to control robots. We have in their very first year, they build robots out of Arduino microcontrollers, and they write the code in C to do that, C++ actually. And they also create documents like their essays and their posters, and all of their assignments are done in a typesetting language called LaTeX, sometimes pronounced LaTeX. It's LATEX.
Okay.
And that's how they do all their assignments and things. They also learn how to solve physical engineering problems with computer code. So, you know, someone will give you some kind of an engineering problem, and you have to sit down and figure out a program that can logically figure out the solution using the computer. For example, one of the projects in my computational methods class this semester is they have to have a sensor collect data for a certain amount of time. And this may be temperature data from an engine, or wind speed data, or moisture level in the soil, things like that. And they collect it for a certain amount of time, and then they have to write computer programs which analyze that data and extract the important information out of it, so that they can design solutions to problems they might find, or at least monitor the situation. Really interesting and fun stuff.
Yeah.
Actually.
Hey, I'm gonna challenge you, Dr. T, a little bit out there in regards to some of the stuff that I've been reading up on the education component when it comes to new technologies. So, flash notes. And I'll give you kind of a view of this, and then you can tell, hey, that could work or in my classroom or not. But
sounds good.
Just remember the days of doodling on the side of your spiral notebook. Hey, do you remember that geezer? I think he does, maybe not. While you try to take copious notes from your boring biology teacher, would you be more motivated if you knew that your notes would not only give you an edge on the exam, but also earn a bit of cash? Wow, yes. Flash notes allow students to upload their lecture notes and sell them to other students who need more help or resources. The rating system allows the best note takers to get more business, and the general pool of knowledge expands as students continue to share their work with one another.
Okay. See, I don't agree with those kind of things like flash notes.
Okay.
What I'd rather have is students not even taking notes at all. What I'd rather them do is actively pay attention and learn. And we give them a textbook. I wrote a textbook for one of the courses, and they can go home and read the textbook if they want. As far as notes, I'd rather them pay attention and do hands-on things. And this uploading your notes for cache, well, one thing that does help get students' attention and help them take more pride in their work is if they know their work is going to be displayed to everybody else.
Yeah.
So, for example, we have it so that your projects will be put in front of everyone, and they can all judge your projects next to theirs.
It's kind of challenging each other.
A pride issue.
Yeah.
And then we also give prizes to the top ones voted by the students. For example, in my prize I'm giving out tomorrow is one of the Fisher space pens, the pens that were designed in space to write in space.
That's another story. We'll have to expand on that sometime.
The top guy's getting a space pen.
Yeah, that's cool. Okay, so I'm going to throw another one at you. It's called Lore. Okay, have you heard of that?
What's it called?
Lore.
L-O-R-E. Okay.
So Lore is a new startup is using Facebook-type platform, riding the wave of what works and tailoring it for education. This social network allows professors and students to communicate, follow one another, and discuss classwork and lectures. In addition to the social aspect, it allows to document uploads for calendar sharing and grade book options. So why is this better than Facebook? Simply put, social networks aren't always the best place to develop academic networks. Students can follow their professors and interact with them without worrying about the compromising photos from a crazy weekend
most
party.
Most schools already have that. Ours is called Canvas. At NDSU, it's called Blackboard. Every school has this kind of thing already.
Okay.
That we interact and upload and
okay.
download things.
So it's just a different name.
It's just a different name.
It's happening out there. You know, as we wind down here, something really came to my mind in our segment between segments we had here talking to Dr. Terry Pilling from University of Mary is that he wants the University of Mary and their engineering school to become the Midwest MIT.
That's right.
Is that? I'm not overstating that.
No,
that's your vision,
MIT
right?
Of the Midwest. Yes,
all right. I think that is so cool because we have so much talent here in this state, and I'm not just saying North Dakota. I mean the whole Midwest, and need to take advantage of that talent. And why not become the new?
Our students are from the rural areas. They've grown up on farms, and they know how to fix things. They know how to work with machines and throw bales around. They've got a serious advantage before they even get to college.
Well, hey, thanks a lot, Dr. T, for being here with us this morning. I'll be back next week talking about new technologies in energy. So thanks again, and may everybody have a safe and blessed day out there. This is Rockin Dave Blair.